Okay, good morning, everybody. Hope you're doing well today. So, we're going to continue to discuss Chapter 7, Section 2. We are discussing operations with matrices. In the previous couple of chapters, I showed you how to use matrices to solve various systems. In this section, the few lessons that we're going to do, we're going to talk about adding, subtracting, multiplying, and sort of kind of dividing, not really dividing. It's kind of like trying to divide fractions. You don't actually divide matrices, but I'll show you how that works whenever we get there. But today we're going to do basic arithmetic operations with matrices. So if you can see this first example here, it says to add the following matrix. So the first thing that you want to double check, as I said in the previous video, is that all of the matrices are of the same order. You cannot add and subtract matrices if they're not the same size. So you can see that these are all 3 by 1s. They have 3 rows and 1 column, so we can add them up. And adding matrices is as simple as just looking at the corresponding elements within each matrix and adding that together. So you can see I circled the -1, 1, 0, and 2. If you add all those numbers together, we get the number 2 right there. The next row, you can see there's a 1, there's a 2, there's a -1, a 1, and a -3. When you add all those numbers together, you get -1. And then the last one, you have -3, 2, 4, and -2. And when you add all of those numbers together, you end up with +1. So your solution is a matrix that is also a 3 by 1. That's something to keep in mind when you add and subtract matrices. The solution matrix will be of the same order as all of the matrices that you added together. And the solution matrix, as you can see I'm highlighting, is 2, -1, 1. So this is pretty simple. Now this one says use the distributive property to solve. So what I would actually do first here is I would follow PEMDAS and I would work inside of the parentheses. So you still have this scalar on the outside, this 3, that we're going to leave on the outside, but we're going to combine the first two matrices and we're going to add the corresponding elements. So we have -2 and 4 right there. Those two are going to add together, to give me 2. And then we have 0 and -2. Those two are going to combine to be -2. We have 4 and 3, which gives us 7. And then we have 1 and 7, which is 8. So first we added the two matrices together. Now we're going to distribute that scalar, and that scalar actually distributes to every single number inside that 2 by 2 matrix. So this 3 is going to multiply the 2, it's going to multiply the 7, it's going to multiply the 8, it's going to multiply the -2 like that. So all of those things are going to get multiplied by 3. And you can see when I do that, I end up with 6, -6, 21, 28. Now, this is a little bit harder. This is called a matrix equation. And what they do is they give us this equation right here, this 3x plus a equals b, and they want us to solve specifically for this variable. Now, the one thing I want you to note there, and I had mentioned in previous class sessions, and especially with WebAssign, you have to be careful that WebAssign doesn't capitalize, I'm sorry, your iPad doesn't capitalize letters whenever you're typing them into WebAssign because WebAssign will mark them wrong. Well, this is why. Capital letters in math mean different things, and one of the main things that capital letters mean is they represent matrices. And so if you look in this expression that I have highlighted in orange, 3x plus a equals b, the x and the a and the b are all capitalized. And they are capitalized because they represent matrices. And you can see that here by how they defined a and b. All right, so we have this equation that I've highlighted in orange. And before you can solve and get this solution, you have to solve this equation. So the 3x plus a equals b is we're going to subtract a from both sides, okay? And so we end up with 3x equals b minus a. Now from there, it's still not solved. So we need to divide this side by 1. I'm sorry, I was going to say 1/3, but we need to divide by 3, and then we need to divide this by 3. Multiplying by 1/3 would be the same thing. And actually in matrices, that's actually what you would do. You would multiply by 1/3. instead of dividing everything by 3. So you get x equals b minus a, and then that answer, everything gets divided by 3. So this right here, what I just solved for, and I'm going to highlight it in light blue, this right here, this is our directions as to what we are supposed to do with this matrix A and this matrix B so we can solve for x. All right, so if you look at what I highlighted in blue, it says take B and subtract A, get your answer, and then divide that matrix, all of the individual elements, by 3. So that's exactly what we're going to do. I'm going to write it out, though, because it'll make it a little bit easier to understand. Here's B, -3, 2, 4, 1. We're going to subtract away 1, -2, 0, 3, like that. Okay? And so once we do that, we're going to divide the whole thing by 3. So you can see that -3 minus 1 is -4. 4 minus -2 actually becomes 6. 2 minus 0 is 2. 1 minus 3 is -2. And now all of this needs to be divided still by 3. And when I divide that by 3, I end up with this matrix right here. -4/3. 6 divided by 3 is 2. And then we have 2 divided by 3, which is 2/3. And then we have, lastly, -2 divided by 3, which is -2/3. There's your answer. So here's another example of a matrix equation and how to solve it. The first thing we do is we look at the actual equation that we have and we determine what do we need to do to get x by itself. So we're going to add a, and then we get 2x equals b plus a, and then we're going to divide both sides by 2. And you can see x equals, I'm going to switch the a and the b around. So it's a plus b. You know, addition of matrices is commutative. You can switch the order. As a side note, multiplication is not. So the order matters for matrices. It's different than regular numbers, but we'll talk about that later. So what this is saying, I'm going to highlight it. This says in order to get our answer x, or our matrix x, we need to take the matrix A, we need to add it to B, and then divide all of the individual elements by 2. So let's do that. You can see I have A right here and I have B right here. And so when I do A plus B, I get 6 plus 4, which is 10. I get 1 plus -1, which is 0. I get 0 plus -2, which is -2. And then I get 3 plus 5, which is 8. So now that's just A plus B. So this is A plus B. Now we need to take that whole thing and divide all of those by 2. And when I do, I get 5, 0, -1, and 4, which is my answer right there. Okay, so you can see this isn't that difficult. You just got to make sure you're not making arithmetic errors. Okay, now matrix multiplication. This is a little bit different than adding and subtracting. There's a lot of, in this slide, and I attached these slides as a PDF to the Google post in Google Classroom. You can read those if you want to. I'm not going to read them to you. I think it makes it more complicated. I'm just going to show you an example. There's one thing that I do need to show you, though, before we do an example, and that is how to determine whether two matrices can multiply. So if you remember in my previous couple of examples, I said in order to add and subtract matrices, you had to have the same size matrices. And so everything had to be the same. The row and the column had to be the same in both. So I had a 3 by 4 can add to a 3 by 4, right? But a 3 by 4 can't add to a 2 by 3. In multiplication, that is not necessarily true. You don't have to have all of the numbers matching. You only have to have the two center numbers matching. Okay, so as an example, if I had a 2 by 3 and I wanted to multiply it by a 3 by 4, those two could actually multiply because the center numbers match. And even strangely enough, their answer will be a 2 by 4. And if you noticed where the 2 by 4 comes from, that comes from the two outer numbers. And this is another thing that I just mentioned, 2 minutes ago. Matrix multiplication is not commutative. So you can't multiply them in either order and get the same answer. And it actually has to do with how the multiplication is done. And so in this example, if you had a 2 by 3 times a 3 by 4, if you tried to multiply them in the other order, a 3 by 4 times a 2 by 3, you can see that these two numbers right here do not match. So therefore they wouldn't multiply. So it is important whenever you try to multiply matrices, the first thing that you check is that their orders are correct so that you are able to multiply. And those two center numbers have to match. Once they match, your answer will be the two outer numbers. And then you have to multiply them in that order. All right, so there's my graphing calculator. We're going to go into, excuse me, we're going to go into the matrix. We're going to go over to edit, and we're going to call this first matrix A. As you can see, it is a 3 by 2, so we need to make it a 3 by 2. And then we are going to enter in the data. So it's -1, 3, 4, -2, and then 5, and then 0. Now I'm going to hit second quit, and now I'm going to go into matrix again, over to edit again, and matrix B is a 2 by 2, and then I'm going to enter my data in there. So it's a -3, it's a 2, it's a -4, and it's a 1. So there is the data for the second one. So I've entered in the matrix for A. I've entered in the matrix for B. Now all I got to do in the home screen, you can see I hit second quit, is I just need to tell the calculator to multiply the two matrices together. So if I hit second matrix and I choose matrix A times second matrix, choose matrix B, I hit enter, you can see I have -9, -4, -15, 1, 6, 10. And if you look over here, I scroll down, that's the solution right there. So matrix multiplication is really not bad if you're using your graphing calculator. It's actually quite easy. You just have to make sure you put the correct elements in each matrix. So this one asked me to find the product of D and E. So I'm going to go over here and we'll hit second matrix again. We'll go into edit. Let's scroll down to, let's utilize the D matrix. That is a 3 by 3. And we're going to get 0, 4, -3, 2, 1, 7, 3, -2, 1. Then we can go into second matrix and we're going to go over to E, enter our data in for that. That is a 3 by 2. And so we have -2, 0, 0, -4, 1, and 2. Hit second quit. And now I can go second matrix again, and we want to do matrix D times matrix E, and hit enter, and there is your solution. -3, -22, 310, -5, 10. There you go. All right, so hopefully that made sense. Shouldn't be too bad, just using your graphing calculator. And actually, I'll mention now, the first couple of examples that I showed you where you are adding and subtracting matrices, the calculators will do that too. If you enter them in for the A and the B and the C or whatever you choose to call it, and then you, in the home screen, tell it what to add or subtract, it will do that just fine. So, all right, have a good day. Let me know if you have any questions.